All right. What about the audio and video online? What about the audio and video? Right. Okay, it's working fine now. We'll start. Right. Good afternoon, all. And yeah, that's fine. And welcome you all to 28th batch. Right? Yeah, starting today. You are just after your O levels, and you are also freshly starting your A level journey. Right? So, how was O levels before A levels? How was it? You did good, I know. Right? Even at the online also, you can put your responses to the chat. I can see. Right. So, first thing, since most of the students are like when you are coming from O levels to A levels, since most of the students are asking questions about the subject, stream selection, maybe combinations, subject combinations, right? Those things, I will spend like few time before jumping onto our syllabus, right? I will be starting the syllabus today itself, right? But before jumping onto that, since you are still, some of the students are still making your decisions, no? Whether you are going with combined maths or bioscience, or if you are combined maths, whether you are doing chemistry or ICT, likewise combinations, those questions are there, right? In these first weeks, right? So therefore, before jumping into the lessons, jumping into the units, right? First, I will give you a rough idea about what you can do here and what are the paths available, everything, right? Otherwise, now ultimate goal of doing the respective stream and with a subject combination is reaching your final target, maybe the anticipated degree, or after the anticipated degree, that field that you want to be in. That's a thing, no? Right? So therefore, first I'll spend some time explaining how you should do here, and kind of a comparison from O levels and A levels, because now since you are freshly have come up after O levels, I know still you are in O level mindset and everything, but when it comes to A levels, that is kind of different, right? That is kind of different, but it takes some time to you to adapt, right? That's true. Otherwise, I don't say now from first day itself you can be that exact A level student who you're supposed to be. No, that's not the case. That's common for anyone, right? That's common, but more earlier you come into that track of A levels, more easier that you will be doing A levels, right? That's the thing. The worst case is if you didn't understand it until you are doing the first attempt, even, right? Then maybe you don't like to do it, but you have to do it. Second day, right? Then more earlier you come on to this track, right? Because there's a ratio, but more earlier if you come onto the track, which means more easier that you will go along this journey, right? You are climbing up the ladder, right? Okay. Right, in online also, I think now you are joined, right? Okay. Listen, have you started other classes already? Started, right? Okay, listen. So first I'll give you a background idea about the streams first and the combinations, right? Because still there are students who are kind of having doubts whether you are choosing maths or bio. එහෙම අයත් ඉන්නවා. ගණන් හදන්න පුළුවන්. ඒ කියන්නේ maths වලට එකක් තිබ්බ කියලා maths කරන්නද එහෙම එකක් නැහැනේ. Right? That is totally up to you. Right? And those are not the things that you should look at when you are selecting that. That should be your final goal. Right? The degree, basically the degree course that you are going to go, you wish to go, and the field. Right? So if you need to be in engineering field, this is how you should be. If you need to be in medical field, that's what you should do. Likewise, that's the answer, right? Okay. So basically, this is what's here. This is called science stream, right? This is called science stream. This is called science stream. This is called science stream. And in science stream, two main streams are physical sciences and biological sciences. Right? Physical sciences and biological sciences. Physical, this is called physical science. Right? Physical science කියන එකට තමයි ඔය කට්ටිය maths කියලා කියන්නේ. මම මෙතන ලියන්න නැතුව ඉන්න physical science එකට තමයි කට්ටිය කියන්නේ ලේසියට maths කියලා. That is called physical science. Right? And this one bioscience. The other one is bioscience. Right? These two are the two main streams we have. And when it comes to these streams, we have a prominent subject combination and optional subject combinations. Right? Prominent combination in physical science is, physical means what you say, maths. Right? Prominent subject combination is combined maths, chemistry and physics. Right? Yes. There is a prominent subject combination, the prominent one, most prominent. And when it comes to bioscience, it's like this: biology, chemistry, and physics. Right? When it comes to this combination, right? When it comes to this combination, before saying opportunities, let me introduce you the next combination as well. This is first combination and the prominent one. No? And the second combination is, I think you already know. If you are doing physical science, you have an alternative for chemistry, right? That is ICD. Then in that case, you are replacing chemistry with ICD. Maths, physics with ICD. With ICD. You are replacing chemistry, yeah? You are replacing chemistry with ICD. And here also you have, this is a prominent combination, right? Prominent combination. And you have options. What can you replace if you have ever think of? No idea. If you are choosing biological sciences, main combination is this, the prominent combination is this. What are the other options we got? Without doing physics, you can do agriculture, right? Without doing physics. Then it is like this. Then you do biochemistry and biology, chemistry and agri. Agri means agriculture. Agri. Something like this, right? But these two are the prominent combinations. Prominent and main. Main combination means that has a highest competition. Highest competition in the sense, highest number of opportunities. Because competition is not artificial. That is something naturally made, right? Naturally made in the sense, that is how it naturally happens. It happens because of the opportunities it creates, right? Basically now, after the first degree, BSc, you are stepping into the corporate sector, no? Right? Which means you are basically starting a job, right? You are basically starting a job. Maybe you are continuing MSc or any other things, but as the first thing, will be going to a respective field, no? Right? Then with those salary scales, job market and everything, this competition changes, right? If we are choosing something less competitive, this means in terms of salaries also, that same impact is there, right? Okay, that's a basic idea. That's the basic idea behind this, right? Now, about this combination, if you are going with this combination, combined maths, chemistry and physics, first thing is, the reason to say these things are there are some students who are doing this combination, right? Thinking that they can apply for engineering degrees, and after 3 months down the line only they get to know that they can't do any engineering subjects, engineering disciplines, right? That's why I'm explaining this, because now if you are deciding this during the first week or maximum during first 2 weeks, right, then you are on the correct path and you can continue your things. For this 2.5 years of A-level journey. That's basically a 2.5 years journey, right? Okay, now if you are doing this, these are the opportunities. If you are doing this first combination, main field that you are exposing to is engineering, right? When it comes to engineering, there are different fields, right? You are exposed to any field of engineering, right? Different fields. Like now, when it comes to our university, our means Morodo University, we have 13 different fields, right? Fields in the sense maybe civil engineering, electronics, electrical, logistics, textile, earth resource. So likewise, 13 different fields, right? For any engineering degree, if you wish to go, right, this is the only combination you should do. That's the only combination. And after engineering, the other degrees are like other degrees in the sense with the popularity and the job market, engineering. Then in physical science degrees, physical science. If your plan is to be in the academic sector, as an example, lecturing, being a professor, being a lecturer in a university, right? For that, this is the path you should go through physical science, right? If you need to be a physics lecturer in a university, then you can do physical science and doing physics as the main subject and doing a special degree in physics, and then you can step into that field and you can continue, right? Engineering, physical science. Other than that, software engineering and all IT fields, all IT means all IT degrees, and surveying, these are the kind of prominent ones. May IT wala AI, deep learning, AI, deep learning, everything, right? All IT degrees, and so on and so forth. As a number, here you have around 70 degree courses that you can apply if you have this combination, right? As a number, starting from engineering to the very last one, as a number, you have around 70 degrees that you are qualified to apply with this combination. To apply කරන්න ඕනේ requirement එකක් තියෙනවද? Minimum requirement, minimum eligibility of applying, that is this. මේ combination එක තියෙනවා නම් apply කරන්න පුළුවන් for around 70 degrees, right? And if you do this combination, you are limited to ICT degrees. ICT in the sense IT related degrees, right? You are limited to IT related degrees. Now in this case, you are limited to only for IT degrees, right? Other than IT degrees, there are some degrees which are open, right? Open in the sense for several combinations, they can do open. Then for open ones also, they can apply, right? So mainly in IT, the most what we call the job market and the salary scales are high degrees nowadays it's all in Morodo. Now, first one is AI. It was introduced like 2 years back. Only 2 batches are still inside, right? But when it comes to research scores, now they have gone very much high because of the fast growing this thing of the IT sector, right? And there is something called Morodo IT, MIT, right? MIT means Morodo IT, right? Prominent degree and AI. These two, Morodo IT and AI. From Kaltura district, it varies around 1.8, 1.9, and from Colombo, it's more than 2, right? More than 2, something like that, right? And as a number here, it is around 15. It is around 15, right? In other universities, I mean, including all other universities like Calania, University of Colombo, UCSC, degrees and everything. Considering everything, it's around 50. So this difference is there, right? This difference is there. Now, if you really need to be in the IT sector, it's no worries, and it's totally fine that you are doing this. If you really need to be in the IT sector, that is something we have to decide, because there are students who love doing IT, right? Maybe from the childhood. And then if you are like such a student, then this is fine. This is fine. Still you have physics, and in terms of instead of chemistry, you have ICT, right? And with the scope also, ICT is like 1/10 of chemistry, 1/10. Okay, it's a very, very less scope. Huh? If I compare with chemistry scale at the current not there. So it's up to you. It's up to you. ඒකත් එක්කම තමයි competition එක එන්නේ. Right? Now, if you do chemistry, that value of the degree is very much high. Compare කරන්න බෑ. Value is very much high. Right? එහෙම තමයි වෙන්නේ. So as a number, it's like this. හදිස්සිය හරි දැන් මේකේ say you are targeting engineering but you miss this, right? You have many like secondary, tertiary options, right? හැබැයි මේකේ options ටිකක් අඩුයි. That's there. හැබැයි ICT, ඒ කියන්නේ IT field එකේ ඉන්න ඕන නම් මේකම කරන්න ඕන කියලා එකක් නැහැ. All these IT degrees are also inside this, if you do this combination, right? ඒ කියන්නේ මේක තමයි advantage එක තියෙන්නේ. This is the most competitive and the advantageous combination. And this is what most in the sense, the most and the highest ratio of the students are doing, around 70 to 80 are here, right? Around 70 are here, something like that. And about this, before that, any questions on this? Because usually you get doubts, that's why I'm explaining this. But if any things to know, what's your plan? You are doing maths, bio, maths, biology, bio, maths. We also maths. So from this physical science stream, physical science means this is what we call maths. This is what we call maths, physical science. Any questions on this? Anything to clarify about the combinations or anything? Or maybe degrees or anything? No? All good? Right. Now, this competition is not something artificial, right? Make it in naturally, you know, I think. Now, if you compare salary with engineering salary with something here, this is like 1/4 of this. Making 1/4 of it. එහෙම ඩිෆරන්ස් එකක් තියෙනවා. ඉතින් ඒ ඩිෆරන්ස් එකත් එක්කනේ ඔය හැදෙන්නේ. නැත්නම් දැන් සැලරි එකක් අඩු ඩිග්‍රී එකකට කවදාවත් ලොකු කම්පිටිෂන් එකක් එන්නේ නැහැ. ඒක නැචරලි වෙන්නේ නැහැ. right? ඒතර ජොබ් මාකට් එක වැඩි, සැලරි රේන්ජ් එක වැඩි, රෙපියුටේෂන් everything. කොහොම ටික වැඩි ඩිග්‍රී එක තමයි ඉතින් ඔටෝමැටිකලි උඩට එන්නේ. මේ AI වලටත් වෙන්නේ මේක. Now AI was introduced 2 years back. Just 2 years. මොරටු IT කියන එක it's around 15 years now. Right? After being introduced. Still, Morato IT තමයි first එකේ ඉන්නේ, but AI is now at the second place. And all other software engineering degrees in Calania, UCSC means University of Colombo, ICT degrees, they are all passed by this one, AI one. AI කියන එක emerging field එකක්. ටක් ගාලා ඒතර ඒ degrees උඩට යනවා. එහෙම එකක් තියෙනවා. AI is like fast growing now nowadays. ඊට පස්සේ deep learning එකක් මෙතන තියෙනවා. මේ deep learning එකත් එහෙමයි. එයා fast growing. ඒතර ඒ වගේ fields ටක් ගාලා උඩට එනවා. ඒ benefit එක තියෙනවා. right? Basically මෙන්න මේක තමයි වෙන්නේ. right? If you need to be here, the most valuable degree program here is engineering. Doesn't matter which field you do, right? Field is up to you. I mean, if you are not willing to be in front of a screen for like 15-16 hours a day, then you should not be choosing computer science engineering or electronics, those sides. That is up to you, right? Now, if you love civil engineering, then you can go that way, you can choose that, right? Engineering selections are always done inside the university, which means now once you are in the university, then after the first semester exam, field selections are done, something like that, right? නිකන් idea දෙන්න කියනනම් the most popular degree from engineering now is popular in the sense higher salaries, right? Nowadays is electronics and telecommunication engineering, University of Morocco. Electronics and telecommunication, ENTC, electronics and telecommunication. Basically starting salary is around 350 to 400, somewhere around starting salary. And workload is also there, I think. Okay, that's enough now. Then about this biology, chemistry and physics, this is the prominent combination here. And if you do this, the main degrees that you all know, it's medicine, right? It's medicine. When it comes to medicine, now it's also like engineering. Medicine is in different universities, in state universities, and there are like slight differences about the fields in each, right? That you can get to know later, right? Main degree is medicine. Right? And if you need to go here, only combination should be this, like this. Only combination should be this. Medicine or even anything related medicine you can't do. Practical medicine related किसी में देख करना बे मैं कहते हैं मैं engineering किया किसी में related देख करना बे if you do ICT, right? Okay, common popular degrees are wet, molecular dental, likewise total, if you list everything up, it's around 70, right? It's around 70. Make like 70 to 80. This is around 70. Right? With open degrees and everything, open and everything. But if you need to be in agri field, right? Agri means agri-related things, agriculture-related fields. One second. Give me 1 second. Okay, if you need to be in medicine related fields, maybe MLT can medical laboratory sciences, right? Somewhere down the line around 9-10 degree, but still this is not accepted. Medicine related किसी में देख करना बे, simple as that, right? Simple as that. And if you are doing agri, there are some separate degrees that you can go with this combination. From agriculture, food science bad, other food degrees, food and nutrition or like agri related, right? So as a number, it's around 10. Right? So mainly, this is what you should understand first. These two are the main two combinations, and now this combination is also done by a considerable amount of students, like considerable in the sense kind of a substantial amount, around 20-25%, because of the fast growth of IT sector, right? IT sector option. Okay, so basically this is how you should select here. This is how you can select here. You can do the selections here, right? Any questions now? All good, right? If any questions, online ones also, if any questions, feel free to put in the chat. If any questions, feel free to put to the chat. So I guess it's clear up to here. If any clarifications needed about what I explained here, please ask. I'll give you like 1-2 minutes so I can respond to your doubts and we can move on. All good? What about online? Put a thumbs up if it's all good, or you can type that it's clear. And even after this, if you got any doubts, right, feel free to contact me. That's fine, right? I explained because you should know this. You should know this before starting, before you are jumping into this journey. Because if you decided this after like 3 months down the line, that first 3 months is not going to be that productive and efficient the way that it's supposed to be. වැඩක් නැහැ දැන් ඔයා කෙමිස්ට්‍රි කරන්න ඉන්න කෙනෙක් ICT කරලා ඊට පස්සේ කෙමිස්ට්‍රි වල ගියාම අර ෆස්ට් යුනිට් එකත් මිස් වෙලා. ඊට පස්සේ ෆස්ට් යුනිට් එකේ තිබ්බ දේවල් දන්නෙත් නැහැ. එකපාරට මැදින් යන්න වෙන්නේ. Then you have to spend some more time to be comfortable with the subject again, right? So the best option is this, deciding this at the very beginning. Deciding this at the very beginning, right? Okay. So that's why I explained this. Okay, it seems all good. Okay. All right. Okay, then now if you are in any of these three sets, if you are in any of these three sets, you have physics as a subject, right? If you are in any of these three sets, and by mistakenly or somehow if you are here, you are not supposed to be here. Simple as that, right? Okay, now about the subject. About the subject, listen. Listen. Right. So about our subject, about our thing, it's like this. First, tell me, what do you know about physics? What is physics? Now you are here to learn physics, no? What is physics? First of all, before learning the subject, you should know what this subject is. A-levels කරාට පස්සේ කවුරු what is physics කියලා දන්නෙත් නැහැ. ඒකුත් තිබිලා. එහෙම කට්ටියක් ඉන්නවා. බලමු ඒකුත් තිබිලා. හැබැයි දන්නේ නැහැ මොකද්ද කරලා තියෙන්නේ කියලා. Right. What do you know? I mean, what do you think? Your thoughts about physics? What kind of a subject is that? Online ones also can put your responses to the chat. What do you think? What are your names, by the way? Buddhu. Meenu, Pri. Texted me to my number. No, I don't know who. There were like 4, 5, around 4, I guess. 4 inquiries came. and they said they are coming physically. Right. Okay. So, what's your thought about physics? What's your thought about physics? No idea. No idea. Okay. No, nothing at all. Even a single word, by a single word, can't you explain what physics is? Oh, what do you think? No, you can't say, I mean, it's not possible to be zero because you are touching on some parts even in O levels, right? So it cannot be zero anyway. I know you know, but you are I kind of shy to say. What do you know? Yes. Any thoughts? හරි ෆිසික්ස් කියලා මොනවද මෙච්චර කරලා තියෙන්නේ? Newton's laws. Ah, okay. So at least you know about Newton. What else? Physics කියවන Newton මතක් වෙන්නේ ඒකත් හොඳයි. That's a stance he has made. Physics කියව ගමන් what comes to your mind is Newton. That's it. I mean about the scientist. Okay, listen. So basically, physics is all about natural behaviors and phenomena. It's all about natural behavior and phenomena, right? Which means now once you say the motion, now Newton's law is about motion. No, motion is a behavior. Motion is a behavior. If someone changes its velocity, acceleration, or any other variables over time, that's a behavior, right? The other main component here in physics are phenomena. What are phenomena? What are phenomena? Phenomena in the sense, you know about reflection of light, refraction of light. They are phenomena, right? They are not a behavior, but a phenomena, right? So there are like hundreds of them, and there are hundreds of behaviors, hundreds of phenomena that we'll be learning here in such subject, right? So mainly, physics is a study on natural behaviors and phenomena, right? About natural things. Since there is natural, the subject is very much practical because this is about like day-to-day things you see, right? Day-to-day things, and maybe I can explain how you are sitting here just by using one law, something like that. Natural things. Natural in the sense, that is what we have done even from the very beginning. But sometimes you haven't looked into that from that aspect. That's the thing, right? Now, when I'm standing here, that's also because of physics. But we haven't never like given a thought. How can I stand like this? Right? Okay. So basically, that's about this. And so first thing, what I wanted to say is this subject consists of three main parts, right? Three main parts. First one is, the reason to say this is now, whatever the class you go, it should cover all these three, right? That's why I'm explaining here. Right. First one, obviously we should have theories and concepts. No? So we have theories and concepts. Theories and concepts. Right, we have theories and concepts. Right. But as a ratio about the subject, this is like 10%. This is like 10%. Right? A very less ratio of theories and concepts are here. Right? And then the core area here is applications. Core area here is applications. Applications means applications of these concepts and theories. Now, as an example, now since you said about Newton's law, say you learned F equals ma one day, right? Theory is F equals ma, but when it comes to applications, there are like hundreds of types of applications that we can do using F equals ma, right? They are the applications, right? Maybe just to explain the motion of a bus from one bus station to the other, right? That is one of the applications. Likewise, there are like many. There are plenty. And this is like 90% of this. This is like 90% of this, 90% of applications. Right? And last component, last branch here is called experiments. Experiments, and that is also called practicals. Practicals. Right? All experiments and practicals are done by using both of them. Got it? Now, without knowing a theory, we can't go into an experiment, right? And without knowing its applications, you can't go into an experiment again. Right? Experiments are the proofs of these things you do here that you are like going to get the hands-on experience. You are going to witness what's happening here using an experiment, something like that, right? And these experiments are basically done under laboratory conditions, right? Inside the lab, basically inside the lab, right? Okay, so this is the ratio between these two in the subject, right? මේ දෙකෙන් තමයි මේක එන්නේ. So ඒකයි මම මෙතන ratio එක කියන්නේ percentage එකක් ලියලා නැත්තේ. Right? That's why I haven't mentioned any percentage value here. එහෙම එකක් නැහැ. මේ දෙකෙන් තමයි මේක හැදෙන්නේ. Right? Okay, and this is not about marks. Marks allocation එක නෙමෙයි මේ තියෙන්නේ. This is not about marks. මේකට marks තියෙනවා. This is actually 20% of 100% of our paper. මේ marks නෙමෙයි. Right? මේ තමයි scope එක. This is the scope of the subject. මේ scope එක හොඳේ. Marks කියලා හිතන්න එපා. Theory is 10% of marks. එහෙම නෙමෙයි. This is the scope of the subject. Scope means area. Area එක තියෙන්නේ මෙහෙමයි. Right? Simply learning a small theory or few theories, we can do a lot. Something like that. That's why understanding plays some kind of a important role here. Because knowing theories doesn't mean that you can do all applications. Because 90% is done by the applications. No? Theory එක කියලා කියන්නේ පොඩි රෝල් එකක්. අර මම කියව example එක වගේම තමයි. You know F equals ma, which means you know the theory, but doesn't mean that you will tackle all the types of F equals ma questions. ඒ ටික තියෙන්නේ මෙතන. So the core of the subject is here. Core of the subject is here. ඔය සමහර කට්ටිය කියන්නේ theory ඔක්කොම පුළුවන් හැබැයි ගණන් හදන්න බෑ කිය. The problem is here. Theory ඉතින් කොහොමද 10% තමයි. Knowing theories doesn't mean that you will tackle all the questions. That's not the case. Right? Applications වල තමයි මේක priority එක තියෙන්නේ. Theories අර නිකන් parrot කළා වගේ කටපාඩමේ එහෙම තිබ්බත් parrot වගේ theories කියන්න පුළුවන් වුණා. Understanding එක නැත්තම් ඔයාලට ඒක apply කරගන්න බෑ. That's the thing. You know the theory, but you don't know how to apply it to a given scenario. That's the most important point that we need here. That we need here in physics. Right? මම physics ගැන විතරයි කියන්නේ. අනිත් subjects වලත් මෙහෙම තියෙනවා components, right? That you can get to know from the respective teachers, no? Right? And experiments කරන්නේ මේ දෙක verify කරගන්න. To have a verification. As a verification, ඒ කියන්නේ දැන් theory එකක් තිබ්බා කියලා always we are not going to admit it. Right? කියන්නේ මේක admit කරන්න ඕන කියලා නෑ. We can do the experiment, you can get the hands-on experience and check whether it works out. ඒකට තමයි මේ verifications තියෙන්නේ. Right? Okay, and this is about the scope. Then about the structure and the marking. Podi idea එකක් දෙන්නම්. This you will get to know in depth before we are starting the paper class. Right? දැම්ම නෙමෙයි for you. Right? paper class එක start කරද්දී මම paper structure එක මීට වඩා in depth කියනවා. But now to get an idea about how these parts are going to involve here, මම නිකන් format එක මොකක්ද කියලා කියන්නම්. Right? This is how you are going to get in terms of the paper. Consists of two parts, right? Part 1 and 2. Part 1 is MCQ, right? Consists of 50 MCQs having 5 choices, right? 50 MCQs with 5 choices. And each MCQ carries 1 mark. Each MCQ carries 1 mark. Then 1 into 50, right? This is going to give you a whole 50%. This is going to give you a whole 50%. Right? And when it comes to MCQs are made from these two. MCQs are mainly but kind of rare. So mainly that is from these two. MCQs are mainly from these two: theories, concepts, and applications. Right? And in that MCQs also this same ratio is there. May scope ratio then you will get around 10 MCQs from theories and remaining 40 from applications. Something like that. And when it comes to part 2 consists of two sections as A and B. Section A is a structured essay. Structured essay. And structured means, I think you have written structured essays already in all levels, right? Structured means you are given the space, right? You are given the space, the question is given and the space is given, blanks are given, right? So you have to answer to the point as to manage that given space, right? They are called structured essays. When it comes to structured essays, for MCQs, these two are mainly contributing, and this knowledge is like not that strong but really contributing, right? When it comes to structured essays, you are getting four structured essays, four structured essays, and all four structured essays are from experiments. Main must go again right? All four structured essays are from experiments. All four structured essays are from experiments, and one structured essay carries 20 marks out of 200. One structured essay carries 20 marks out of 200, and that is 80 out of 200, right? And for essays, you have 8 essays, right? You have 8 essays to elect 4 out of 8, right? There are ways to do the election, do the choosing of the questions, right? 8 telling 4 it's not like 50%. There are like 4 questions that you can do either part A or B. Basically, we have 8 essay questions from 8 different units we have in physics, right? From 8 different units, right? Then from these 8 essays, you are taking only 4, right? You are taking only 4, and one carries 30 marks, and it sums up to 120 from 200, and this is taken to 50, right? Final 50% from 200, right? That is how it is going to be. And for essays, again, these two are contributing. Structured contribution. For essays, these two are contributing. Something like that, right? So mainly for experiments, you got 20% of marks because 80 means 20. 80 means 20% out of 50. The remaining 50 is taken from this. Then 200 is taken to 50. And 120 means 30 marks, 30% from 100. Right? Then for experiments, 20% means 1/5 is playing by experiments. That's a huge amount. 1/5 of 100 is here. Right? Okay. So this is basically the outline. And when it comes to this class, right, we'll be also doing everything in the same way, in the sense experiments are, we have all together, we had 42 experiments, and very recently 4 experiments related to mercury were removed, right? Now we have 38 experiments throughout the syllabus, and 38 are like divided between units, divided among units. Now, as an example, for mechanics, 1 unit for mechanics, we have 7 experiments. Divide for unit 1 measurements, we have 4 experiments, something like that, right? Experiments you are going to learn down the line. Experiments right? Along with the theories along with the unit activity, ongoing unit, you will be learning the respective experiments. Something like that, right? So here also we'll be covering everything. We'll be covering everything. And this is the importance. This is the importance. මොකද සමහර කට්ටිය එක්ස්පෙරිමන්ට්ස් එහෙම කරන්න නැතුව ඉන්නවා. ඉතින් ඒක ඉම්පැක්ට් එක තියෙන්නේ මෙතන. 20% කියලා කියන්නේ ඒක give up කරන්න පුළුවන්. නිකන් ignore කරන්න පුළුවන් මාක් එකක් නෙමෙයි. 20 means is a 1/5 of the whole thing. Very significant. Even 1 mark is very much significant. 34 නෙමෙයි 74 තිබිලා 75 වෙන 1 mark එක කියනවා. Right? You are swinging between a B and A just because of 1 mark. Then what about 20 marks? Right? Okay. Basically when we make it, and then about the units here. About the units here. Starting from the unit we are going to start today, right? Starting from the unit that we are going to start today, right? We have 11 different units in physics. 11. Right? 11 units. 11 units. And doesn't mean that all 11 are equal in size. Totally different. Totally different. Right? Totally different. 11 different units. Right? That's the only thing. Like unit 1 එක කරන්න 1 month කියලා කියලා unit 2 එක කරන්න 1 month වලින් බෑ. අන්න ඒ වගේ. Totally different. Right? So actually the largest lesson out of all 11 is mechanics unit 2. Right? Unit 2 එකට තොර ඊට වඩා වැඩි කාලයක් යනවා. Something like that. එහෙම compare කරන්න බෑ. We have 11 different units. Okay. 11 units. And today we are going to start the first one, that is called measurements. And the list goes on like mechanics, oscillations and waves, thermal physics, gravitational fields, electric fields, current electricity, electronics, magnetic fields, properties of matter, matter and radiation. Right? මෙහෙම දෙයක් තියෙන්නේ. මේක දැන් කිව්වා කියලා වැඩක් නැහැ. Right? Something like that. And today itself we will be starting off with measurements unit 1. Right? Okay. For online ones about the registrations, you can get to know any info that you need through this number 618-8597, right? Through WhatsApp, right? Or else, right? You can visit this website directly and you can complete your enrollment there. Right? You can complete your enrollment there. And anyway, for online students, join into classes, accessing recordings and everything, exams, everything will be done using the website, right? You can create your account later on before next week, right? Payments and everything, everything is here, right? For today, no requirement, no need. And the other thing about the tutes, for online ones, you will be getting in the sense tute will be getting delivered to the address you are providing in the sense when you are creating the account, it will be asked about a living address, right? Or rather an address to post tutes, right? So mention your correct address there, and that will be the same address that I'll be using when posting tutes, right? If your address changes, you have to change it here accordingly. Otherwise, sometimes for any reason, if you change your address, right, I'll be posting to the address that is mentioned here, that is that you have entered here, right? Okay, if any other questions, any other things to know about the classes, put a message to this number, right? For you also, recordings are gettable, right? For you also. මේකෙම තමයි ගන්න තියෙන්නේ. ඒක මම පස්සේ කියනවා. For physical ones also recordings ගන්න පුළුවන්, right? In any case, if you are absent to the class on a particular day, you can still get the recording, right? This will be recorded and you can get the recording just as the online ones do, right? Everything is there. Right. Okay. Then right. Then let's start off. Anything to know before starting the syllabus, before starting unit 1? Any doubts? Anything? Physics කියලා හිතාගෙන ආපු එක නෙමෙයිද physics කියන්නේ එහෙම වාක් කරේ. එකක් තියෙනවා. No? All good? All good? No? Right. So let's start. Put the heading unit 1 measurements. Unit 1 measurements. Unit 1 measurements. Unit 1 measurements. Give me 1 second. For online ones, I will put a link to the chat. From that, you can get the soft copy of the gift until your enrollments are completed. Right? Give me 1 second. Link at the we'll put link. Since it's the first day. Whenever we need right. Give me 2 minutes. Right. Listen. Unit 1 measurements. Online once you can get the soft copy of the tube using this link that is put on the chat. Right. Click on the link, then you will be navigated to the PDF version of the tube. Right. Okay. Listen. When it comes to measurements, measurements consist of two main parts, right? They are units and dimensions and measuring instruments, right? First one is called, first sub part under this, under measurements, is called units and dimensions. Put that in as units and dimensions. Units and dimensions, right? Now here also we have two parts now. Now from here we are going to start off with units, right? So before coming into units, put the head in and listen. Put the head in and listen. Before coming into units, we have something called, listen now, we have something called physical quantities in physics. Physical quantities. We have something called physical quantities in physics, right? Physical quantities. Right. So first thing is physical quantities. Anyone has heard about the word or come across the word physical quantity? Physical quantities? Oh, no? In thoughts? All right. Different, but අහලා තියෙනවා කරේ idea එකක් තියෙනවා. Okay, now what else you know? What else you know? Physical quantity means something like this. Physical quantity means it should be something measurable with the magnitude. What is a magnitude? Magnitude means a numerical value, number, a numerical value, right? If we can measure, I told you initially, physics is about behaviors and phenomena, right? So if we can measure those behaviors and phenomena, or any aspect of a behavior or phenomena with the magnitude, measurable with the magnitude. Those two are very much important two keywords. Measurable and it should be able to offer or give as a numerical value. That's called the magnitude, right? Such ones are called physical quantities. Right now, as an example, listen, look at the board. Say we need to study about a motion of this object A from this point to here. We need to study about the motion of an object from point A to point B, right? Now, when it travels from A to B, now we should be able to measure this one, right? So therefore, that is called a length. Basically, that's a length, distance or displacement or whatever it is, that is a length. Okay, that's a length. So which means length is what we are going to measure, right? Length is called a physical quantity and unit is a different story, right? Whether you are measuring the length using millimeters, centimeters, kilometers, meters, that's unit. That's about the unit. Quantity එක කියලා කියන්නේ that feature that you are going to measure, right? Can be distance, can be a length, can be time, right? අර feature එක විතරයි, right? If it changes velocity from here to here, velocity is the quantity. That's a physical quantity. And unit is a different thing. To measure a physical quantity, we have to have a unit. ඊට පස්සේ තමයි අර unit කියන idea එක එන්නේ. To measure physical quantity. Right? Now to explain about this. තව විදිහකට කියනවා නම් to explain about an object. දැන් මේක ගන්නකො. This is a marker. Right? To explain about this marker, what are the things I can use to explain about this? නිකන් කියන්න. If I need to explain about this, what are things we can use to explain this, to explain about this? Huh? Mass. So mass is a physical quantity. Measurable, no? So that's a physical quantity. What else? Length. Possible. What else? Cross-sectional area or area. Color, even color is a physical quantity. Color එක measure කරන්න පුළුවන්. We don't have in physics, but it's also a quantity. Color එක measure කරන්න පුළුවන්. There are color codes. කියන එහෙම. ඒක විදිහවල තියෙනවා. Even color is a feature. So likewise, here we have some physical features, no, that is related to physics, right? Now, those features are called physical quantities, right? Now, without saying the word mass, I can't explain what mass is. When it comes to physical quantity, right? When it comes to physical quantity, that physical quantity cannot be defined using that word itself. Mass කියන එක use කරන්න නැතුව මොකුත් කියන්න බෑ. Right? It's mass. Right? The length නම් length from here to here, no? So we have to use the word length again. Something like that. They are fundamentally there. Got it? මේ ඕන එකක් මේ පෙන් එක නෙමෙයි. I mean, not just limited to the pen. If we need to explain about anything, rotational speeds, maybe any other thing, right? If you are using some words, right? Words in the sense, features to explain the behavior of phenomena of this, right? They are all here in physical quantities. So අපි දන්නේ නැතුව හරි දැනගෙන හරි ඔයා explain කරලා තියෙන්නේ මෙච්චර කළොත් they are physical quantities. Time කියන එක දන්නවනේ. Time is a physical quantity. Right? Unit of time is seconds. ඒක unit එක. Unit එකකින් measure කරන්න physical quantity එකක් තියෙනවා. What you are going to measure using the unit is a physical quantity. Right? Okay. Under first subheading, write down physical quantities. Physical quantities. Okay, write down below a measurable property slash feature of a behavior or phenomena. With the magnitude. I think you have already heard the word magnitude. With the magnitude. Slash, put a slash, numerical value. With the magnitude slash numerical value. Is defined as a physical quantity. Right, listen now. When it comes to physical quantities, there are two types of physical quantities we can find in real world, right? First set is called the fundamental quantities. Fundamental means fundamental කියන word එක තියෙනවනේ. The word fundamental itself means, right? That is a baseline. Fundamental means that, no? That's a baseline. Baseline means they cannot be derived using any other physical quantities, right? Using fundamental physical quantities, other physical quantities are developed, right? Such quantities are called fundamental quantities. And we have 7 fundamental physical quantities in physics. We have 7. Only 7, which means all other physical quantities which are not here in this list of 7 are derived ones. Derived using fundamentals. Fundamentals ටික තමයි තියෙන්නේ derive කරන්න. ඒ කියන්නේ fundamentals ටික තමයි මෙතන ඉන්න අර baseline එක. That's a foundation here. And based on that foundation, all other derived physical quantities are developing. They are building up. Got it? Right. So let's see what our fundamental physical quantities are. As a heading, write down fundamental physical quantities. 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 Fundamental. Fundamental physical quantities. Right. Listen. We have 7 quantities here. And based on these 7, fundamental means this. I'm not going to write anything for that. I mean, for the fundamental means they cannot be derived using anyone else. They are fundamentally there. Right? මේක තමයි මෙතන තියෙන අර foundation එකේ තියෙන quantities 7. That's the foundation of this. That's the foundation. Right. First fundamental physical quantities, don't write, just look at the board, is mass. First fundamental physical quantity is mass. Right? Which means mass cannot be derived using anyone else. And in other words, mass cannot be explained using any other word other than mass. Something like that. Just imagine whether can I explain about mass without using the word mass. What is mass basically? Mass of this one is the mass of fundamental particles. Fundamental particles means electrons, protons, neutrons and everything this is made of, no? ඒකේ තන්තිමට මට mass කියලා කියන්න වෙනවනේ. නැත්නම් ඒක explain කරන්න බෑනේ. අන්න ඒක තමයි fundamental එකේ තියෙන property එක. Got it? Mass of the pen means the sum of the masses of all subatomic or atomic particles here. Right? Fundamental particles here. Neutrons, protons, electrons. හැබැයි ඒගොල්ලන්ගේ mass එකනේ. Then again we have to come back to this. Right? Such quantities are the fundamental ones. I hope that idea is clear. Is it? Right? Fundamental කියන එක වෙන කිසිම විදියකට ඔයාලට explain කරන්න බෑ. Without using that word itself. Something like that. Right? ඒකට වෙන substitutions නැහැ. Right? ඒක විතරමයි තියෙන්නේ. Right. One is mass. Then length. Without using the word length, I can't say what this means. No? Right? From here to here, meaningless. Length from here to here, then it's meaningful. හැබැයි මට මේ word එක use කරන්න ඕන. Got it? ඕක තමයි idea එක. Now if you didn't use this word, the whole thing becomes meaningless. Meaning එක එන්නේ මේකත් එක්ක, but it cannot be substituted or there are no any alternatives for that word. Length කියන එකට alternative word එකක් නැහැ. That's the thing. What the idea? Right? Mass, length, what else? Time. What else? I think you have learned in O levels amount of substance. Amount of substance in O level chemistry. What you measured in moles, amount of substance. Then electric current. Right? Electric current කියලා කියන්නේ it's starting from batteries to here to everything covers electric currents. Then thermodynamic temperature. Thermodynamic. Don't worry about the word thermodynamic. We'll explain. Thermodynamic temperature, that is about temperature. And last one, luminous intensity. luminous intensity. Right. From here, listen, from here, mass, length, time, they are understandable, right? Time amount of substance, that is what you measured in moles, right? Amount. And electric current means what you measured in amperes, right? V equals IRA mu square, that is electric current. Starting from a battery to all other AC, DC generators to anywhere, vehicles, anything and everywhere in your phones, watches, shoes, inside watches and everywhere that covers currents. And thermodynamic temperature is about temperatures, right? Temperatures. Usually you measure that in degrees Celsius, no? When it comes to thermodynamic temperature, that is what we call the absolute temperature. Absolute means that is measured in kelvins. That is going to be measured in kelvins. Absolute value, not the Celsius value, right? Absolute value. And then luminous intensity is about the intensity of light, which means basically brightness. Brightness කියන එක measure කරන්න විදියක් තියෙන්න බෑ. Right? Brightness එක measure කරන එක තමයි luminous intensity. Luminous intensity. Right? Okay. Something like this. So mainly we'll be focusing on these three, but we have also one mainly for the proceedings we will be taking these three. Right? For each fundamental quantity, it has a fundamental unit as well. Unit එකකුත් තියෙනවා. මේ තියෙන quantities ටික, then we'll see what units are and what are the fundamental units of these quantities are. So unit එකක් කියන්නේ මොකක්ද කියලා දන්නේ නැහැ, right? We'll come into units later. I mean next. Right. Take it down. Take it down. Mass, length, time, amount of substance, electric current, thermodynamic temperature, and luminous intensity. Take again mass, length, time, amount of substance, electric current, thermodynamic temperature, and luminous intensity. Right? Now think about these things again. Right? So repeating again, the idea is these quantities cannot be explained without using this word itself. They are fundamentally there. Right? Okay. Any questions? Any questions? Clear? Right? Okay. Now let's see what a unit is. Next, somebody in units. Units. Put there in as units. 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 Okay. Listen. Units means something like this. Units. Units means something like this. Now, if we are to measure physical quantity, right, the number itself doesn't give any meaning, no. Now, as an example, let's say length from here to here is 10, right? 10. Does it make any sense? When I say just 10, no. If I say it's 10 centimeters, then it makes a sense, right? Now, if you mention it even without mentioning about the physical quantity, it makes sense, right? Now, I say 5, right? I say 5. No idea is coming to your head. But if I say 5 kilograms, then you know it's about a mass. What's the point? Then units are the standard benchmarks, standards to measure these physical quantities. Now, we know from the definition of a physical quantity, it should have a magnitude. Magnitude is a number. But number itself doesn't give any meaning. Number එකෙන් විතරක් meaning එකක් එන්නේ නැහැ. 10 කිව්වා කියලා we feel nothing. It's 10. But if I say 10 kilograms, then we feel something. If I say 10 meters, ටක් දාලා වාට length එකක් මතක් වෙනවා. If I say 10 seconds, then it's about time. එහෙම idea එකක් එනවනේ. අන්න ඒකට තමයි units කියන જાතිය ඉන්නේ. Number එක ඉන්නේ, number is for the purpose of the magnitude or the comparison. 5 seconds, 10 seconds කිව්වොත් we know 10 seconds is greater than 5 seconds. ඒකට තමයි number එක ඉන්නේ. Right? Unit is as the standard of measuring the physical quantity. That's the standard. Right? Standard එකක් නෙමෙයි, there can be multiple standards as well. Right? The point here is, the idea here is, when we are saying about the magnitude of something, right? Number is not enough. Number is not merely enough. Number එක විතරක් කිව්ව කියලා වැඩක් නෑ. අන්න ඒකට එහෙනම් standard එකක් තියෙන්න ඕන. Right? That is what we call the unit. Got it? Okay, write down below. The standard measurement slash benchmark. The standard measurement slash benchmark. The standard measurement slash benchmark to measure a physical quantity. To measure a physical quantity. To measure a physical quantity meaningfully. To measure a physical quantity meaningfully. To measure a physical quantity meaningfully is defined as a unit. Is defined as a unit. Is defined as a unit. Right, listen. Units are standards, which means they are defined. Which means now when I say 10 meters, right? Meters කියන part එක it's a definition. Meters කියන එක ආවේ කොහොමද කියන එක ගැන idea එකක් නැහැ. කියන්නේ එහෙම logic එකක් නැහැ. Can be as an honor to the founding scientist or for some reason that is there. ඔකට example එකක් ගත්තොත් you know ohms, right? Ohms, resistance is measured in ohms. Ohms is labeled as, or it is stated as ohms as a credit to the scientist, founding scientist. Ohms කියන එකට වෙන concept එකක් නැහැනේ. There's nothing behind ohms. Ohms කියන එක ඇවිල්ලා තියෙන්නේ credit එකක් විදියට. ඒ වගේ තමයි. Meters කියන එක පිටිපස්ස තව මොකුත් නැහැ. There's nothing behind meters. Or we can't say how meters are derived. Because we have to have a base. Base කියන එක definition එක. Base එකේ definitions තියෙනවා. Then based on the base, then we can derive all other things. What's the point? And මෙතනත් එහෙම ඒවා තියෙනවා. Kelvins කියන එක. Kelvins කියන එක ඇයි ඒකට Kelvin කියන word එක use කරන්න කියලා අපිට කියන්න බෑ. Right? It's something as our name. Now, what's your name? බුද්ධිම. දැන් ඇයි ඔයාලට බුද්ධිම කියන්නේ කියලා කියන්න බෑ. Because that is something given by parents. අන්න ඒ වගේ එකක්. Got the idea? මේක given. මේක නෙමෙයි. Units are given. Fundamental units. So the standard units are given. Right? My name is Pasindu. If someone asks why you are Pasindu, there's no answer. That's something given by parents. ඒක අපිට දීලා තියෙන label එක. හරි? ඒතකොට දැන් මෙයාට දීලා තියෙන label එක. ඒකට definition එකක් නැහැ. ඒක define කරන්න විදියක් නැහැ. හරි? දැන් මේක පෙන්නේ. ඇයි මේකට පෙන්නේ කියන්නේ? කියලා අහුවොත් ඒකට definition එකක් නැහැ. මේකට pen එක කියන්නේ that is because you have taught that this is a pen. දැන් මේක කියනවා මේක table කියලා. You are still saying this as a table. That's something you have taught. අන්න එහෙම එකක් තමයි මේ දෙන්නේ. Meters කියලා කියන්නේ that's given. Right? Okay. That's enough. Then respective to fundamental physical quantities, there are fundamental units. Then write down fundamental units. fundamental units. Fundamental units. Fundamental units. Fundamental units. Okay. Now mention the same list again under units. Mention the same list again under units. Under units means now under that topic, fundamental units. Mention the same quantities again. And while writing, try to keep them in mind. If you can like recall and write, it's better. You can recall and write, it's better. Because today onwards, these 7 is something that should be in your mind. Fundamental units. Okay, look at here. Right. Mention all 7 units. Right. Listen. Fundamental units for mass. For mass. What do you think the fundamental unit is? Fundamental unit of mass is kilograms. Right? Kilograms. Now, when you write this K here, it should be a lowercase k, right? Sometimes you might have writing capital K in O levels, right? For capital K, there's a different meaning, right? Thank you. Okay, listen. Mass, kilograms. Then length. Fundamental unit of length is meters. That's a definition. It's given. Fundamental unit of time is seconds. Simple less. Now, simple capital, uppercase, lowercase are very important because for both we have meanings. Then meaning is different when it comes to lowercase and uppercase letters, right? Okay. Amount of substance, moles, right? Mole. Electric current, amperes, right? Amperes. Thermodynamic temperature, that is not degrees Celsius, that is kelvins. Kelvin is uppercase K, capital K, right? Kilo means simple K, yeah? Know the difference. Luminous intensity, it is called candela. Candela, simple C, simple D. Right? I think this is the only one new to you from this list. This is called candela. Candela. Right? And for these ones also, if you need the word, you better mention the word, right? Kilograms, meters, seconds, moles, right? Moles, electric current, thermodynamic temperature, kelvins, candela, candelas or candela. Right? Write it down. Write it down. And if anyone needs these words in words, You can mention within brackets kilograms, meters, seconds, amount of substance, moles. Right, keep it there. Right, thank you. Amount of substance, electric current, amperes, thermodynamic temperature, kelvins. This is candelas. Right. Now, listen. Now, since we know fundamental units, we are going to derive the other derived units using these fundamental units. Got it? Fundamentals එක තියෙනවා නම් අපිට මෙතනින් එහා derive කරගන්න පුළුවන් නේ. Right? Whatever you have heard so far, maybe velocities, accelerations, right? Starting from velocities, accelerations, forces, pressures, right? Nothing is in this list. What's the meaning? Meaning is they are not the fundamental quantities. They are derived quantities. They are derived quantities. ඒ කියන්නේ ඒ ඔක්කොම දැන් derive කරන්න පුළුවන් වෙන්න ඕනේ අපිට. Using just by using this 7. Right? When it comes to derived quantities, there are thousands of quantities, but all are based on this 7. ඒක තමයි fundamental කියලා කියන්නේ. Right? Okay. Now let's see how a quantity is derived using these 7. Right? As an next heading, write down derived physical quantities and their units. 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 Okay, now we'll do one by one. Look at the board first. I will show you what we are going to do here first, right? Look at the board and listen carefully. And then after the second one onwards, you can try. Then I will do the discussion to you to check what you have done, right? Now let's start from a simple quantity that you know, right? Let's start from a simple quantity that you know. Velocity, right? Velocity. Velocity. Velocity is, what is velocity as an equation, by the way? That is displacement over time. That is true, but not true. Not the displacement, that is change of displacement. That is a wrong idea which is coming from all levels. I know every one of you, if I ask what velocity is, every one of you say displacement over time. But somewhere down the line, physics along on the first day itself, and somewhere down the line in maths, if you are doing maths also, you will be seeing velocity is not displacement over time, but that is difference of displacement or change of displacement over time. Displacement නෙමෙයි. That is about a change. That is about a change. Point එකකට displacement එකක් මට define කරන්න බෑ. That is for a region or the range. That is for a range. Right? So therefore, it's about a change. Change means difference. Right? Now, today onwards, don't say displacement over time again. Change of displacement over time. Right? Because that word change is a keyword there. ඒ කියන එක නැතුව අපේ සමහර ඉස්සරහ දේවල් explain කරන්නත් බෑ. Right? That's a kind of a wrong idea coming from all levels. එහෙමව තියෙනවා. Right? Okay. Velocity is, don't say displacement now. Change of displacement. Change of displacement over time. Right? For velocity, we use V as a standard symbol. Right? There are standard symbols. Right? There are standard symbols. There are different meanings. Right? There are standard symbols with different meanings. So that's why we are also using those standard symbols, because they are standard. Right? So wherever we have this equation, then anyone knows that this is about a velocity, this is about a time, this is about a displacement, something like that. That's why the standards are for, right? Displacement, the standard symbol of a displacement is S. Right? And when you are writing change of displacement, we are using delta S. By the way, do you know what delta is? Toffee, anyway. What delta is? Delta. I think you no. Delta. This kind of a symbol. Delta. No. Delta means this is also a standard symbol. Delta is the standard symbol of change or difference. This is SI. Yeah? SI means a standard symbol. This is a standard symbol of change or difference. Change or difference. This is the standard symbol of change or difference. That is called delta. Delta is actually a Greek symbol. It's a Greek symbol, right? Most of the like initial findings of science and physics were originating from that side, no? Greek scientists and comedy. That's why these Greek letters are coming from the origin. Right? Greek scientists and හිටියේ මේ සිංහල වගේ අය නෙමෙයි. They were from Greece and area ගැන අර හොඳම සයන්ටිස්ට්ලා සෙට් එක අයින්ස්ටයින් නිව්ටන් ඊට පස්සේ කෙප්ලර්ලා ගොඩක් ඉන්නවා. The list is goes from there. ඒකනේ තිබ්බේ අර මේ මොකද්ද ඔයගොල්ලෝ හිස්ටරි වල කතා කරන්නේ? ඒක තිබ්බේ හේ. So that's why we are still using these Greek symbols. නැත්නම් දැන් අපිට මේක ඉංග්‍රීසි alphabet code එකකට මේ alphabet එකට දාගන්න පුළුවන් නේ. එහෙම දාන්න නැහැ. Because they were originally coming from there. That's why. Right? එහෙම ඒවා තියෙනවා. මේක අදින් පස්සේ මතක තියාගන්න. If you don't know, you can just take a note. Delta is the standard symbol of change or difference. Right? Now if I need to say change of displacement, that is delta S. Delta S, change of displacement. Delta means change of displacement over time. Now as an equation, we can mention this as V equals delta S over T. Right? Now we are going to check the derived units. Now derived physical quantity can be seen. Change of displacement. Displacement is a length. Time is a fundamental one. See, using these two fundamental physical quantities, velocity is derived. That's why velocity is not in this list. Inside velocity, we have two fundamental quantities. Right? Now, when we are finding the fundamental unit, no need to write anything in words. Right? No need to write anything in words. When we put a parenthesis means simple brackets. Right? Simple brackets, the meaning is units of. This is again a symbol. Units of. Right? Don't write units of velocity using words, just put the bracket, which means units of velocity. Right? Equals units of change of displacement over units of time. Got it? And then plug these units. Now this is how you should do. Change of displacement. Right? You know what displacement is. Shortest distance between 2 points. So that's a distance. Shortest distance, no? That's a distance. Distance is a length from this list. Right? And here there is not a displacement but a change of displacement. Change of displacement means there is about a difference of displacements. Right? So what's the quantity? Resultant quantity. Difference means a subtraction. Difference is subtraction. From a displacement, if I subtract another displacement, what is going to be the result? It's also a displacement. From 10 meters, if you subtract 2 meters, result is 8 meters. Displacement, right? It is never going to be a mass, no? When you subtract 2 meters from 10 meters, can it be 8 kilograms? No. That is also a displacement. Difference there's no change. Then change of displacement is also a displacement, no? Is that clear? Change of displacement is also displacement. Displacement is a length. Then unit of length is meters. Right? And time, that is very straightforward. Time is here itself, fundamentally there. Time is measured in seconds. Unit of time is seconds. Then time should be measured in seconds. If you simplify this, right, it comes to ms minus 1. Got it? That is how the quantity and the unit is getting derived. This is a simple example of what's happening. Right? We will see what is happening for the popular physical quantities here. Right? Not all the ones you have throughout the syllabus. That you will get to know along the way. Right? First unit, but the popular ones will derive. Right? So that is what is happening. Right? Pretty simple maths part. Now, if you have 1 over x, you can write this as x to the power minus 1, no? Right? So that is what I have used here. Right? Is that idea clear? Not a big deal, a simple thing. Is that clear? Right? Online? Is that clear enough? If any doubts, you can ask, you can raise questions. If not, take it down. Take it down. Thank you. What are your schools? Excellent. All three. Excellent. You? Ashapur. You are from Taxila. So if you are not aware of these things about brackets, you don't know that I know, make a don't know, because we will be using this throughout, right? And if you are not aware of delta, right, you can mention delta is always difference, and any difference in maths and physics is considered as the final value minus initial value. Always final minus initial, that's a standard. Any delta means any change is written as final minus initial, right? If you need displacement, final displacement minus initial displacement. If you need velocities, final velocity minus initial velocity, right? For anywhere and everywhere, that meaning is same. Meaning is same. Okay, finish. Okay. Let's try another one. Second one. As the second one, derive acceleration. Okay, again, what is the general equation of acceleration? We denote by simply acceleration. Now again, more or less the same thing, not velocity over time, but change of velocity over time. Not velocity over time, change of velocity over time. Don't say velocity over time, right? Don't say velocity over time. There is change of velocity over time. X, no, I just mentioned to show the index simplification, right? If you take something in denominator to the numerator, it becomes minus 1, no, index becomes minus 1, no. That's why. Right. Acceleration. So don't write velocity now, change of velocity. First mention the equation, change of velocity. Velocity is v, then change of velocity is delta v. Over time, simple t. Don't put capital T, because for capital T also there are different meanings. Right? Different meanings here. Right? Then we have to stick to all the standards. Standard right. I think some equations are put onto the tube as well. Right? So you can see some of the equations here. Right? And I know you are familiar with most of the equations here. Right? Sorry. You are familiar. Right? Do this working and derive. Change of velocity over time. Now, this is how you should think. Change of velocity. Change of velocity is a difference of velocity, no? Then final velocity minus initial velocity. It's a velocity minus velocity. Velocity minus velocity gives a velocity. Is that clear? Velocity minus velocity gives a velocity. Quantity ka marula enna? Velocity minus velocity is a velocity. Then in terms of the unit, right? Now this is acceleration equals delta v over t, right? Unit of a equals unit of delta v over units of t, right? Then units of acceleration, right? Let me plug the value here. Delta v, this is how you should think. Delta v, change of velocity. Change of velocity is a velocity. Change means difference, or in other words, subtraction. If you subtract a velocity from a velocity, the result is also a velocity. Right? If you subtract a velocity from a velocity. Right? And the other thing is, other beauty of this is, we can't add or subtract any two different quantities here. Again, can we add 10 kilograms to 10 centimeters? Can't do. Contradictory. No meaning at all. That is contradictory. Right? Kilogram value එකක් එක්ක add කරන්නත් පුළුවන් නැත්නම් subtract කරන්නත් පුළුවන් kilogram value එකක් විතරයි. That's only a mass with the mass. Right? ඒතර difference එක ලියද්දිත් ඒකම තමයි මේ වෙන්නේ. Right? When you take the difference, that's a subtraction of these two. That's a subtraction. Velocity minus a velocity, the result is a velocity. Right? Then we know velocity is measured in ms minus 1. That we have proved already. Velocity is measured in ms minus 1 over time is seconds. Simplify this, ms minus 2. Right. Clear enough? Right? Let's move on. Next. Let's see something you know again, like force. Force. Basically, we use capital F for forces. What is the fundamental equation you know for force? F equals ma, mass into acceleration, right? Then mass, for mass we put simple m, and acceleration simple a. Okay, try it. Mass into acceleration. Online ones, you also can send your answers to the chat. Yeah, right. Finish. Correct. Yeah, correct. Okay. Listen, look at here. Force, mass into acceleration. So basically, that is F equals ma. This is what you are familiar with. F equals ma. If you are finding units of force, units of parenthesis, units of mass times units of acceleration. Right? Units of mass. Mass is a fundamental one. Kilograms. Right? Mass is kilograms. Kilograms. Into acceleration, that is here. ms minus 2. ms minus 2. Then it comes to kg ms minus 2. kg ms minus 2. But this is not the unit that you are familiar with. What's the unit you are familiar with? Newtons. Right? Newtons. Now, when it comes to units, first do this, then I'll explain. If you have any rectifications, any changes to be made, first complete it before the explanation. kg ms minus 2, it's correct. It's correct. But this is not what we are familiar with. Okay, listen now. There are some of the physical quantities, right? Some of the physical quantities in the world, or some of the units in the world, right? Their fundamental unit is replaced by an honored unit in the sense, if there is a founding scientist, and if someone needs to give a credit, give a respect to that founding scientist, right? There are some units, they are labeled as the name of the scientist, name or the part of the name of the scientist, as an honor to the scientist, right? That's a name, no? That's a name, that is something given. Then it cannot be in the fundamental list again, right? Now, here also, same thing happened. Same thing happened. Fundamental unit is kgms minus 2. But as an honor to the founder, founding scientist of all these unbalanced forces, researchers, uniform velocities or motion, basically motion, is Sir Isaac Newton, no? Then as an honor to that scientist, this was recognized as Newtons, right? Newtons. You can make a label. This is naming as Newtons, as an honor. Then a respect. That's a credit for the scientist, right? And that is actually considered as the SI unit. SI means Standard International, right? SI means SI, Standard International. This is what we will be using here onwards. SI units, Standard International. Now, when this is labeled as Newtons, then kgms minus 2 was named as Newtons, and Newtons is considered as SI. This is considered as SI. When this becomes SI, this becomes the derived unit now. This is called the derived unit. This becomes the derived unit. Correct? This is not the SI anymore. It's wrong. No? It's wrong. This is not the SI. SI then all other units except the SI unit is derived units. Right? All other units. Sometimes there can be like 3, 4, 5, 6 derived units for the same quantity. All are derived units. There's only one SI. There's only one SI. Right? Okay. Write down below. Don't write this. Write down below with a red pen. Write down below with a red pen. If you didn't bring a red pen, bring a red pen next day onwards. Right? Online ones also. Right? If you don't have a red pen right now, if you don't have a red pen right now, bring a red pen next day. And if you have any different color other than what you have been using, you better to use it. Because what I'm mentioning in red is these are the special points. Right? Special points in the sense, right? The main logic of this one is mentioning in red, right? Now, when you study this again, right? Just check what is written in red. Main logic. Okay, write down in red. But SI unit of below this one, mention this in red. Mention this point in red. But SI unit of force is named as Newtons. Newtons, N-E-W-T-O-N-S, Newtons within brackets capital N. Right? And then write this down and you can highlight to square this and label these two as SI and derived unit. Finished. Right? Such quantities are there. Now, if you need to break down Newtons, right? Into fundamental, right? Now, we have to keep this in mind. If you need to break down Newtons, then just know that Newtons equals kgms minus 2. Right? Equation use particularly for F equals ma, it works, but that is not working for all. F equals ma because force is measured in Newtons, mass is kilograms, acceleration is ms minus 2, Newtons equals kgms minus 2, it satisfies, right? But it, it's not always working for all, right? Now, what we are highlighting here, you are squaring what you are highlighting here, right, should be the conversion between these two. You should know that's a conversion, right? Wherever you need to convert newtons into fundamental units, this is a conversion, right? Back and forth, if you need to convert kgms minus 2 to this side, newtons to kgms minus 2, back and forth, we can use this, right? Okay, let's move on. Next, 4. Pressure. What is the equation of pressure? Equation of pressure, capital P, force over perpendicular area, right? Force over perpendicular area, force, capital F, over perpendicular area, we denote by capital A. So as an equation, P equals capital F over capital F over A, right? Okay. Right. And by the way, what is area? You know, right? If you break it down, what is inside area? Area කියන එක list එකේ නෑනේ. Area is not in the fundamental list, which means area is also derived quantity. Fundamental එකේ නැත්තම් very simple, that is derived. Area කියන derived. From what? From what quantities or which quantities area is derived? Basically, area is length into width, no? Length into breadth or length into width. Length is length, width is also length. Then length into length, that's the fundamental idea. Okay, right? Finish. Right. Substitute units and substitute units now and get the derived unit. Yeah, good. Yeah, simplify it. Simplify. Always when we keep the final unit, we are keeping the unit on a single line. Again, fractions, don't keep fractions, right? Simplify your index and take it all to the numerator. Take it all to the numerator. Right? Yeah, මුලින්ම derived unit එක හොයාගන්න. මේ derived එක නෙමෙයි. First find the derived unit. There can be some other units you have come across already, right? First find the derived unit. We'll go one by one, right? First find the derived unit. First you can find the derived unit. See? Units of pressure is given by units of force over units of area, right? Perpendicular area, right? If you don't know about area, again you have to expand area, right? And dive in and see what is inside area, right? Now when you dive in deeper and deeper, at the last end you will see a fundamental one. පටන් ගන්න ඕනේ fundamental එකකින්, right? මොන unit එකකින් මොන physical quantity එකකින් start කරා, right? If you dive in step by step, right, the last step is going to be the fundamental, right? That's the exact meaning of a fundamental, right? Now area is not a fundamental, but we know area is, right? If anyone don't know, area is length into width or length into breadth, right? Now check what is here. Length is a length and width is also length. length with height, everything are lengths. This is also length, right? Then here what we are doing is that's a length times length. Fundamentally, fundamental simplification here is a length times length, right? Then length times length means length times length means, right, meters into meters, squared meters, something like this, right? If someone needs, right, now you can substitute force. First we will go with the fundamental ones. Fundamental unit of force is kgm is minus 2. Kgm is minus 2 over fundamental unit of area is m squared, right? Simplify this. When this comes to the numerator, plus 2 becomes minus 2. Then m minus 1 is, sorry, m plus 1 is here, right? Plus 1 minus 2 ending, that's minus 1. Then kg m minus 1 s minus 2. Is it? kg m minus 1 s minus 2. Now something like this. Listen, so I hope all of you have got this, the fundamental unit. This is the fundamental unit of pressure, right? Now, if we simplify this again step by step, right? Step by step, we know kgm is minus 2 is also Newtons, no? It's Newtons. Now, from here, if you directly plug, I'm taking this here. If you directly plug Newtons here, you are getting another different unit, right? Now, this can be written as or considered as Newtons, no? According to that, then Newtons over m squared, that is nm minus 2 Newtons per square meter, right? This is also a possible unit. Right? And this is unit 1 now, fundamental. This is the second one, 2 units. And none of them are the SI. What is the SI unit of pressure? Pascals, right? Pascal is the founder. Yes, scientific name Marian. Pascals means founder. Then this is replaced by Pascals. Right? This is replaced by Pascals. Then altogether we have three possible units for pressure. One is SI with two derived quantities. Derived units. Got it? එහෙමයි වෙන්නේ. SI එකයි දෙන්නේ. අනිත් ඔක්කොම derived. There can be any number of derived quantities for a given physical quantity. Derived units. There can be any number of derived units for a given physical quantity. Right? Derived එකයි දෙන්නේ කියලා එකක් නැහැ. Right? පාක් හයක් හතක් any number basically. Any number තියෙන්න පුළුවන්. Right? And when it comes to questions, we should be able to find them all. When you are asked to find all derived quantities, then we have to find all. Right? So that's better if you do this with this kind of a flow. You can hurry the fundamental, right? That's a flow, no? Fundamental ones. And then this part of the fundamental is replaced by Newtons, right? I want to replace then you can do that replacement. So likewise, when you move on, you won't miss any. Got it? Lazy. All right, take it down. Finished? Right. Write down below with a red pen. But SI unit of pressure is, SI unit. SI means standard international, right? But SI unit of pressure is but SI unit of pressure is pascals. Pascals. But SI unit of pressure is pascals. But SI unit of pressure is pascals, right? Which means, see, which means pascals means PA, right? PA is equals pascals ke dala within brackets you better mention PA, right? In that statement, in that sentence. But SI unit of pressure is pascals within brackets capital P simple A, right? Which means pascals equals Nm minus 2, right? Equals this one kg m minus 1 s minus 2. See, now 3 units, 3 possible units to measure, and this becomes SI. Only this is SI, and these two are derived now. Derived. And this is also called the fundamental unit. Listen, this is also called the fundamental unit. Right? Expand. This cannot be expanded further. So that's a fundamental. That's a derived one. It is also called the fundamental unit. Take it down. Okay. Right. Next. 5. Number 5. Linear momentum. Linear momentum. Linear momentum is also labeled by capital P. Now, in such cases, they are contextual. Right? So, again, එකම quantity එක symbol එකක් විතරක් නැති cases තියෙනවා. One such example is this. For pressure also we are using capital P. For linear momentum also we are using capital P. And there is something as angular momentum somewhere down the line. That is also capital P. Then that meaning is contextual. We have to know the context to get the exact meaning. Right? So if there is something related to pressure related now, that's about pressure. But if not, if there is something to momentum, momentum side we have to know both. Right? P මේකට දැම්ම කියලා ආයි මේකට දාන්න නැතුව ඉන්නවා කියලා එහෙම නැහැ. Right? V වලටත් එහෙමයි. Now we are using V for velocities as well volumes. Volumes වලට V දානවා. දාන්න දෙන්න contextual. Right? Okay. Linear momentum. Linear momentum is mass into velocity. Mass simple m times velocity. V. Mass into velocity. V. Right? Linear momentum. Find the units now. Find the fundamental units. And as an equation, this is P equals mv. P equals mv. You have this equation in all of us, right? Mass into velocity. Right. This is easy. Then units of P momentum is units of V into units of M. Units of P is units of mass is kilograms. That's a fundamental unit. And velocity is already proved ms minus 1. So this is kg ms minus 1. Right? Kg ms minus 1. Right? No substitutions. Nothing. This itself is the SI. This itself is the SI. SI is kg ms minus 1. Right? Okay. Next one. Work. Capital W. What is the equation? of work? Force into displacement, not the distance. Force into displacement, right? Force into displacement, don't say distance, right? There's a difference, right? So there can be like slight differences of what we have learned in O levels when it comes to here, right? So what we are using here is the exact equation, right? Then you have to upgrade yourself, upgrade your knowledge to this level starting from today. Because for some reason those things are not mentioned in O levels because I don't think there's a that kind of use, such kind of a use in O levels. Displacement use කරා කියලා ඔයා හදන ගණන් මොකුත් වෙනස් වෙන්නේ නැහැ. Distance දැම්මා, displacement දැම්මත් එකම answer එනවා. But in here that's two different things. Right? Now it matters here. O levels වල එක matter වුන්නේ නැහැ. ඒ නිසා අවුලක් නැහැ. මොකක් හරි distance හරි මොකක් හරි කියලා දැම්මා. But now that's not the case. Right? These are the exact equations. Work is force times displacement. Force, capital F, times displacement. Not the distance, displacement. S. Okay, right? Then as an equation, W equals Fs. W equals Fs. Don't write Fd, right? Fs only. Don't write Fd. When you find units, you can follow any order. You can either start from fundamental and you can do in that particular direction, or else you can start from the top one and you can go down until you reach the fundamental, right? So either way, we have to make sure that you are not missing any unit in between. That's the purpose. That's the purpose. Yeah, correct. Then if you see any other derived quantities, maybe derived units, try to convert to the derived ones as well. Try to convert it to derived ones as well once you got the fundamental, right? If you have got the fundamental unit, right? If you can see any other derived units or any other replacements for that fundamental unit, right? You can try converting it to another derived unit. Finish. Okay, good. Right. Finish, right? Okay. See, units of work. Units of work is units of force times units of displacement, right? Then units of work, units of force. If I start with the fundamentals, fundamental unit of force is kg ms minus 2, right? Into this displacement that is measured in meters. Displacement is a length measured in meters. Then this is kg m squared s minus 2, right? One of the units, kg m squared s minus 2, right? kg m squared s minus 2. Then you can check whether any other replacements are available, right? Here we have kg m s minus 2, no? That's a direct replacement, that's a direct substitution of newtons. Then you can replace this part using newtons if needed, right? Then newtons times meters, that is called Newton meters. Newton meters. Another unit, that is unit 2, Newton meters. right? And SI of work is none of them. What is it? Joules. That is joules. Again, same meaning, same idea. Joules is an honored unit. Right? That's a founding scientist. Right? Then we'll be replacing both by joules. Right? So first finish it up to here. There are two units here. There are two units here, but none of them is the SI. Write down below with a red pen. Write down below with a red pen. But SI unit of work. But SI unit of work. But SI unit of work. But SI unit of work is joules. Joules, joules. But SI unit of work is joules. Within brackets, capital J. Capital J. Capital J. Right. Which means joules equals Newton meters equals kg m squared is minus 2. Right. Write this down and highlight. To play around with these units, convert back and forth, we have to know these expansions. That's the importance of that. Okay, as the next one, go to kinetic energy. 7. Kinetic energy. Kinetic energy. Right? So you know this equation also from all levels, right? We usually put Ke, kinetic energy, half times mass m into velocity v whole thing square. Right? Then kinetic energy equals, as an equation, kinetic energy equals half mv square. Half mv square. Half mv square. Okay, try it. Before I explain anything, give it a try first. What about half? What about this half? Now, if I apply parentheses, units of kinetic energy should be units of half into units of mass into units of p squared. No? That's the concept you have learned. Right? It is derived using the equation. What about half? Half is a number. Half is a number. Right? You are doing a unit simplification. Right? Half is a number. Then what is the unit of a number? I didn't give you any hints. Just give it a thought and tell me what's the unit of a number? Numbers 1, 2, 3, 4, likewise. What's the unit of a number? There's no unit, right? They are called unitless terms. Numbers are unitless. Number unit. right? They are unitless, right? If we are doing a unit simplification with unitless terms, right? For the ease of our simplification, we put 1 instead. 1 in the sense unitless, right? 1 kilo, 1 means unitless, right? We'll mention this after this. This is unitless, right? Unitless 1 kilo for the ease of simplification. Unitless 1. Don't put 0. 0 it's 1. And putting 1 is not mandatory, right? That is just a denotion, a symbol to say that is unitless 1. Right, now apply the rest. M kilograms, velocity, ms minus 1, complete squared. I have to simplify this, right? Kg m squared is minus 2, right? Now, mistakenly, if you simplify it with this half, you will get kg ms minus 2 over 2, something like this, right? No meaning for this, right? No meaning. Now, if I explain this using a known unit, say you are measuring something using meters, right? Then we say 20 meters over 2. What's the meaning? No meaning at all, right? That's why we put 1 here to avoid that simplification and make our simplification easier, right? Because we are not doing a mathematical simplification here. This is called a unit simplification. You are just simplifying the unit only. Numbers name, just the unit. Unit take simplify kare. Now make the unit. Right? No contribution from half as it is unitless. No contribution for the unit. Unit take contribution. Right? Even if you skip writing this, that's totally fine when you are finding units. Without writing 1, if you skip writing this 1, that's also fine. Right? So that is kg m squared is minus 2. So this is something we knew. What is it? Yeah, that is what we got for work. Kg m is minus 2, right? Which means this is also equal to both of them. This is also equal to both of them. Same thing. Then joules equals I only. Which means for kinetic energy, let me mention this way, right? All these 3 units are also applicable for kinetic energy. Right? No need to do this simplification again, no? Because we have already proved that kg ms minus 2 equals Newton meters and that is joules. That is joules. Right? Then kinetic energy. There are 3 units now. Joules, Newton meters, and kg ms minus 2. Kg m squared is minus 2. Right? As the next one, go to gravitational potential energy. Gravitational potential energy. Right? 7. Sometimes you might be using it as potential energy, right? It is fine until O levels, but when it comes to potential energies, there are different types of potential energies. That's why we are specifying as gravitational potential. There are different types. Gravitational potential energy, right? GPE, mass times gravitational acceleration. Gravitational acceleration, simple G, into vertical height h. So as an equation, gravitational potential energy equals mgh. They are familiar equations to you. Okay, 5 minutes again. 5 minutes. Finish. Same, right? And what about gravitational acceleration? Now, even though it is gravitational, right, there is an acceleration at the end of the day. Gravitational acceleration is an acceleration, right? An acceleration units present. Right, simplify this. Gravitational potential energy, mass, Gh. Right. Then units of mass, kilograms. Units of gravitational acceleration is an acceleration. Then ms minus 2 into height is a length, meters. Right. Simplify again. Then kg m squared is minus 2. Right. Same thing again. Which means units of gravitational potential energy is also same as these three. Right. Mention again. Mention again. Units of gravitational potential energy is also same as joules or Newton meters or kg m squared is minus 2. Right? And from here we will conclude something. Listen, that is units of any energy or work are always same. Any form of energy. Now I just showed you two forms of energy, right? Maybe sound energy, heat energy, strain energy, elastic potential energy. For any form of energy, right? These three units are varied, right? And for any form of work, right? For work also there are different forms of work, like work in linear motion. Now these are the work in linear motion, and there are work in rotational motions, angular motions, different things, right? But as a whole, keep in mind that units of any type of a work and energy, like work or energy, are these three, right? That's always can be written using joules as the SI, right? Mention this point in red below. Mention this point in red below. Units of units of units of units of any form of energy. Units of any form of energy. Units of any form of energy and work are same. Are same. And work are same. Right. 9. Power. This is also capital P. Power. Power. What is the equation of power? Work over time, work divided by time. Or that can be also said energy over time, because work and energy are same now, right? In terms of units, means in terms of all other aspects, that's same, right? Then you can write this as either work over time or energy over time. Work over time, right? Work over time. It is also fine. Or you can also write this as energy over time. Any form of energy, I just put E, energy over time, right? Okay, find it. You can find all possible derived units. Find all possible derived units. And make sure you have found everything. Finished. Finished. How many derived units? 3. 2 or 3? 3. 3. Except SI. 3 derived units. With SI, 3 units. There are more. What about online? Fundamental unit is correct. Fundamental means the first one is correct. Finished. Bring a red pen next day. Finished. Finished. Then 3. Yeah. Right. Same no? Same. Same. Yeah, there are 3 derived units. Listen, there are 3 derived units. When you do the simplification, do it step by step. That's what I mentioned before. Otherwise, if you miss something somewhere, right? In a question where you are asked to find all possible units, you won't get full marks. Okay, let's see. Power. Now, as an equation, this is work over time. Now, if you need to find units of power, units of work over units of time, right? You can start from any end, right? Doesn't matter whether it's the top end or the bottom end. Doesn't matter, right? I did these ones from the bottom end, no? Now, to show you, I'll do this from the top end. You can get used to any direction you prefer, but have some kind of a like pattern, a flow. A flow එක miss වුණොත් එහෙම, if you miss something in between, then you won't find it again. That's the thing, right? Okay, I'm going to start from the top end. Now, as SI, we can measure work in joules, right? And time in seconds, right? Then it gives Js minus 1. Js minus 1 first unit, right? Now, we know how to expand joules, no? Here, Newton meters. Joules can be expanded as Newton meters, right? Then at once here, joules can be expanded as Newton meters. Then this should be Newton meters over seconds, right? Joules can be expanded as Newton meters. Simplify this. It gives Newton meters per second. NMS minus 1. This is another possible unit. That is another possible unit, right? Now, check whether any other expandable ones exist. Yes, it does not, because N, Newtons is there. Newtons is not a fundamental, right? If you can't expand further, which means it has to be the fundamental unit. If you can't expand further, right? If you can't break it down further, which means you are in the fundamental. And you can make sure that you have done everything starting from here to the fundamental without missing anything in between, right? That's the purpose. Then Newtons can be expanded. Joules were expanded as Newton meters. Now Newtons can be expanded as kg ms minus 2. That is for Newtons. And we have another meter here, seconds here, right? Simplify. Then this is kg, right? Kg, m into m squared creates m times m squared. Here we have s minus 2 and denominator you have s again. When you take this to the numerator, it becomes s minus 1. Then s minus 2 times s minus 1 means s minus 3. Index simplifications, s minus 3. Then this is the third unit. And now check whether there are any expandable ones. Kg cannot be expanded. That's a fundamental one. Meters cannot be expanded. Seconds cannot be expanded, which means this is the fundamental unit. Right? Okay, we have found everything starting from the top. Right? And about this also, the beauty is that none of them are the SI. What is SI of power? SI unit of power, watts. Right? Watts. Then with that, it has 4 units altogether. Right? Write down in red. Write down in red. But SI unit of power is. But SI unit of power is. But SI unit of power is watts. WATTS watts. Within brackets, capital W. Within brackets, capital W. Right. Which means the relationship among them are watts equals Js minus 1 equals NMS minus 1 equals kg m squared s minus 3. Take this down. You can use them anywhere when you do a conversion. If you need to do a conversion. Okay. Right. Any questions or any doubts up to this point? All clear? All good? All good? Online? Any questions or doubts up to here? If any questions or doubts, feel free to ask. Any questions? Right. So if no questions, I will give you a small exercise. Right? So let's see. Right? I'm going to give you a small exercise. Listen. 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 Now, when we are defining something, defining a ratio or a fraction, right? Always we will define this as x per unit y, right? X per unit y, something like this. X per unit y. As an example, you know equation of density, right? Density equals mass over volume, no? Density equals mass over volume. Rho equals MOV. Right? Density equals mass over volume. So density is defined as mass per unit volume. Mass per unit volume. Always this denominator term is considered as unit term. Right? Another example is velocity is change of displacement over time. Then this is change of displacement per unit time. But per unit time, we have another thing in maths, in physics and maths both. Unit times are again defined as rates. Unit times are defined as rates. So therefore, without saying unit time, as a single word, we use rate in this kind of a case. So this is defined as rate of change of displacement. Rate of change of displacement. Right? Now in this case, this is mass per unit volume. Right? So likewise, always this term is considered as unit term. Right? If there are more than one term, then both are considered as all the terms are considered as unit terms. Right? That's the idea. Right? The reason to say this is Now, if I say something like this, if I say, linear momentum per unit force, then you should be able to write that fraction. Linear momentum per unit force. Per means they are the denominator. Per terms and the method. Per terms are the denominator. Right? And other terms are the numerator. Right? So if you have no idea on this, take this down as a note. Make on a phone now. Right? And this is mass per unit volume. Mass per unit volume. This is an example. Mass per unit volume. Mass per unit volume. Mass per unit volume. Right? So likewise, always unit terms are coming to the denominator. Okay, now let's do a small exercise from what we have learned so far in units. Right? Write down this as a question. Write this down as a question. Find all possible units for. Find all possible units for. Find all possible units for. Find all possible units for kinetic energy per unit volume. Find all possible units for kinetic energy per unit volume. Find all possible units for kinetic energy per unit volume. Kinetic energy per unit volume. Okay, that's it. That's it. First, take it to the fraction. Now I have given it as a question, right? Go through that description, go through the question, and take it out as a fraction. So once you have a fraction, then you can do these unit simplifications. And I need you to find all possible units. All possible units. Which means you have to make sure that you have found all. Right? First try to write it as a fraction. Right? Use kinetic energy as K. Use K for kinetic energy. And try to write as a fraction like this. Fraction corresponding to what I have given. And for volume also we are using V, I told you, right? Contextual, right? For volume also we are using V. Yeah, what is it as a fraction? Kinetic energy divided by volume, right? Kinetic energy per unit volume is this. Kinetic energy divided by volume. Right? Mass per unit volume, x per unit y, kinetic energy per unit volume. And this is not velocity, right? This is a volume. Be mindful, right? Kinetic energy per volume, right? Now I need all possible units for this ratio. Correct. I need all possible units for this ratio. All possible units. And tell me how many units you got. All possible units, all possible units. Finish? No. Finish? How many different units? More than that. Check carefully. Ask if any questions. How many minutes? Finish? Buddhima, right? Finish. How many you have got so far? Three. There are more. Okay, let's start from here. Right, kinetic energy by unit volume. Right. So fundamentally, we can measure kinetic energy is an energy, any energy using joules. Right? Any energy using joules. Let me write this way: unit of kinetic energy over units of volume. Then kinetic energy or any energy is joules. Over volume is length into width into a depth, right? Width and depth are also lengths, no? Then that is length into a length into a length. Cubic meters, meters into meters into meters, cubic meters, right? So first, if you don't know this, right, you can find it out first. Length times width times depth. Length is also a length, width is also a length, depth is also a length. That is cubic meters. Right? Cubic meters. Then this is cubic meters. First unit is joules per cubic meter. First one, joules per cubic meter. Right? Joules per cubic meter. Right? Now, joules is expandable, no? Right? then expand joules. Expand joules. Next, as a second step, we can expand joules as Newton meters. Newton meters, right? Over m cube. Simplify this. Simplify this. 1m2, 1m from here cancels, right? 1m2, 1m from here cancels, only 2 remains. Then what is remaining here is this, right? Simplify this. That is nm minus 2. nm minus 2, this is second unit. Right? Now, Newtons is expandable. Right? Expand Newtons. Expand Newtons. Newtons can be written as kgm is minus 2 over m squared. Simplify this. Then kg. Simplify this. M minus 1. S minus 2. Another unit. Unit 3. Right? Yeah, other than that, other than all of them, the other next one is rest is should be Pascals, because this is a good point that you can see. Nm minus 2, right? Nm minus 2. Nm minus 2 is a unit of pressure. Unit of pressure. Which means, what's the meaning? The meaning is this ratio represents the pressure. Right? This ratio represents the pressure. If you check the fundamental unit you have got for pressure, that's same. Right? Which means as another unit, we can say Pascals. Then 4 units all together. Correct. So that's how we find possible units. Right? Always you have to make sure that you have found all possible units. Right. Take it down. The idea of this is the ratio of kinetic energy by unit volume represents the pressure. That's the meaning. That's the meaning. Pressure ke units are vegan. So that's a pressure. That ratio is a pressure. But that is not something we knew. Right? I gave you some ratio and you did some work in, and now only we can say it's a pressure. Right? So that is also one use of units. Right? We can do some work in and we can check whether it's a known physical quantity. You can see what is inside. You can identification of physical quantities. Right? There are some other things also to identify physical quantities. Units can also be used to identify physical quantities. Okay, finish. Write down below with a red pen. Write down below with a red pen. Write down below with a red pen. Hence, kinetic energy per unit volume. Hence, kinetic energy per unit volume. Hence, kinetic energy per unit volume. Hence, kinetic energy per unit volume is pressure according to above answers for unit scale, above answers for units. According to above answers for units. Right. And keep this heading written prefixes for units. Prefixes for units. Not the prefixes you have learned in languages. Right? In languages also we have something called prefixes, no? Right? Okay, here in physics also we have, right? I will continue the discussion next day from here. And prefixes means, if I just give you an idea, prefixes means, as an example, now fundamental unit of mass is what? Fundamental unit of mass is kilograms. Kilo is a prefix. Grams is the base unit. Right? Now when we say kilometers, kilo is the prefix. Right? Prefix is something which comes in front of the unit, no? Prefix, that's a literal meaning, no? then meters, kilometers, millimeters, centimeters, decimeters, right? The part which comes in front is the prefix, right? So there are like number of prefixes that we will be looking at, right? We'll be looking at, and prefixes will also contribute the conversions between units or among units, right? If you are converting some millimeter values to, let's say, nanometers, then we are using prefixes, or nanometers to kilometers, right? At once we can use a prefix. That's why otherwise now we can't keep everything in mind as dividing by 1000, dividing by 100, multiplying by 100. So that's why we have some standard sets of prefixes. Then once we know the value of prefix, right, easily we can do back and forth conversions. That's the purpose of prefixes. And the other purpose is we can shorten a given number using a prefix, right? So there are a few things to be discussed about prefixes. And listen, now today we have like 50% completed in units. This is not a like large part. This is comparatively a small part. Comparatively small part, right? So by next day, probably we can finish off units, and then we can start dimensions. I told you part 1 consists of units and dimensions, right? It consists of units and dimensions. Now we are still in units, and we are like 50% completed in units, right? There are few other things to be done. And next day we can first we can finish units. We will finish units, and if time permits, I will start, right? Most probably I will start dimensions. This is the part 2, I mean next part of measurements, units and dimensions. We are going to go with dimensions, right? And the fixed time for this class will be this, right? From Tuesday 3 to 6 is a fixed time for both online and physical. This is conducted as a hybrid class, right? If any inquiries, as I told you, you can contact that number, right? If any inquiries, and if any other questions or anything to know from me, from my side, you can ask now. Any other questions? Is it all clear about what we have discussed today? All good? Online? Is it all clear about what we have discussed today? Clear, right? Okay. Right. And now this is like this. Next day, I mean day 2, will be a continuation of this. Then having everything that we have discussed so far, right, in your mind, right, is mandatory, right? Now otherwise, if you forget these basic simplifications and those things, right, it is going to be connected to second day, right? So make sure you are going through this again, right? And if you have a leisure time, you can practice these once again and check whether you can find all these units. I did only one example here, one question here, right? There are many types. After dimensions, we'll start doing some questions from the tube, because there are some combinations and there are few things. Okay, and go through again. Otherwise, just by one day, you are not going to be the best at this, right? That is your continuous effort and that consistency, and that is the same consistency we have to keep up until we are sitting for the exam, right? If you lose that momentum, which means you will lose your grade, you will lose your marks. Simple as that, right? If you didn't lose your momentum, definitely you will achieve what you need to achieve, something like that, right? Now starting from today, right, first day onwards, get into this rhythm, right? Now since you are just after O levels, if you are going any trips or going on any trips or any other things, that's fine, right? And limit it to like 2-3 weeks or maximum 1 month maximum. You have to come into this track, right? Trips that's the thing, right? Because if you are doing this here, I mean A levels, it's easy to manage and easy to focus, right? So if you are You need to spend some time with family, friends. I mean, need to go on a trip for somewhere, outing. This is just the first week we have started now. And by 2-3 weeks maximum, you can come into this track. You can, if you are like choosing classes still, you can attend multiple classes and check whether what's going to work with you and finalize classes, right? Those are critical. First 6 months classes switch right? Now during the first week, first 2 weeks, right? Just attend few classes if needed, right? And finalize 3 classes for your 3 subjects, right? Then here on you can move on. Classes that should be a decision that you should make, and that must be a decision you should make now, right? That's it. Okay, and yeah, since this is the first day and this was an open day, this recording is available on YouTube as well, right? If needed, you can, if you need to go through this again, you can check this on, you can watch this on YouTube as well. Since it was a free session, I won't remove this, it will be there, right? And for other recordings for coming up lessons, you have to access it through your account through the website, right? Okay, so that's it. And next day we'll be doing this. Please go through these things and make sure that you are well comfortable with what we have discussed up to this point. Then easily we can continue. Okay, it was a day 2 connect right? Okay then, if no questions, we can wind up. Then start working on today onwards, right? And now come to the A-level mentality. Now still you are freshers and you are in O-level mentality, right? First week right? It will take some time. Then after that, you will be kind of matured from the O-level stage, and you will come to that A-level stage, A-level level for the maturity, right? I mean, in terms of the subject, subject. Okay. All right then. Then stay safe and work hard. We'll see you on the next day. Right? Good night and goodbye.